Welcome to our channel. Today we're diving into the cosmos to uncover some truly mind-blowing space facts that will leave you in awe. Prepare yourself for a journey to the farthest reaches of space, where we'll encounter mind-boggling phenomena and cosmic wonders that challenge our understanding of the universe. From the accelerating expansion of the universe to the silent dance of galaxies, get ready to have your mind blown. Let's get started.
Imagine a universe that's constantly growing, stretching its cosmic fabric in all directions. That's our universe. It's been expanding ever since the Big Bang. But here's the kicker. The expansion isn't slowing down. It's speeding up. Like a runaway train, the universe is accelerating outward, driven by a mysterious force we call dark energy. This enigmatic force, invisible to our telescopes, makes up a whopping 68% of the universe's total energy density. Think of it this way. Imagine baking a loaf of raisin bread. As the bread bakes and expands, the raisins embedded within it move farther apart. That's kind of what's happening in our universe, with galaxies taking the place of raisins. The implications of this accelerating expansion are profound. It means that the most distant galaxies are moving away from us at incredible speeds, eventually becoming so distant that their light will never reach us. So the next time you gaze up at the night sky, remember that the universe is not a static backdrop, but a dynamic and ever-evolving entity. Our sun, that blazing ball of plasma that sustains life on Earth, seems like an eternal beacon in the sky. But even stars have a lifespan, and our sun is actually a relative newcomer to the cosmic scene. In the grand tapestry of the universe, most stars are far older than our sun, some dating back billions of years before our solar system even formed. Imagine a star nursery, a vast cloud of gas and dust where stars are born. Within these cosmic clouds, gravity pulls matter together, causing it to collapse and ignite, giving birth to new stars. Some stars, like our sun, are relatively small and cool, burning steadily for billions of years. Others are massive and hot, living fast and dying young in spectacular supernova explosions. Take, for example, the red giant stars, ancient behemoths in the twilight of their lives. These stellar giants have exhausted the hydrogen fuel in their cores and have expanded to hundreds of times the size of our sun. Or consider the white dwarf stars, the remnants of stars like our sun that have burned through their nuclear fuel. These stellar embers are incredibly dense, packing the mass of the sun into a sphere the size of Earth. So the next time you look up at the night sky, remember that you're not just seeing points of light, but a vast and ancient collection of stars, each with its own unique history and story to tell.
In the vacuum of space, no one can hear you scream. That's because sound, as we know it, requires a medium to travel through, like air or water. Space, on the other hand, is a near-perfect vacuum, devoid of the air molecules that carry sound waves. Imagine yourself floating in space, surrounded by the breathtaking beauty of stars and galaxies. You try to call out to a fellow astronaut, but your words are met with an eerie silence. No matter how loud you shout, your voice will never reach their ears. But don't despair, space isn't entirely devoid of sound. NASA's Voyager spacecraft have detected the eerie sounds of interstellar plasma waves created by the movement of charged particles in space. These plasma waves, converted into sound waves, reveal a symphony of hisses, crackles, and whistles. So while space may be silent to our ears, it's not entirely devoid of sound. In the vast expanse of the cosmos, galaxies are not static islands of stars, but dynamic entities engaged in a cosmic dance of epic proportions. And sometimes those dances get a little too close for comfort, resulting in spectacular galactic collisions. Right now, as we speak, our very own Milky Way galaxy is on a collision course with our galactic neighbour, the Andromeda Galaxy. Don't panic just yet. This cosmic clash won't happen for another 4.5 billion years. But when it does, it will be a sight to behold, albeit a slow-motion one on a cosmic timescale. Imagine two swirling whirlpools of stars, gas and dust slowly approaching each other, their gravitational forces pulling and tugging at each other. As they draw closer, their spiral arms distort and stretch, creating tidal tales of stars and gas that stream out into space. The galaxies will pass through each other, their stars and gas clouds interacting in a complex gravitational ballet. While individual stars are unlikely to collide directly due to the vast distances between them, their orbits will be disrupted, scattering them into new trajectories. Over millions of years, the two galaxies will repeatedly merge and separate, their structures gradually merging into a single, massive, elliptical galaxy.
Chapter 5. Tiny Titans. Black holes, those enigmatic objects of extreme density and gravitational pull so strong that not even light can escape, often conjure up images of cosmic monsters lurking in the hearts of galaxies. But what if I told you that black holes can be surprisingly small, some no larger than an atomic nucleus? These miniature marvels, known as primordial black holes, are thought to have formed in the extreme conditions of the early universe, just moments after the Big Bang. Imagine a black hole so small that it could fit on the tip of a pin, yet containing the mass of a mountain. These tiny titans, despite their diminutive size, still possess the same incredible gravitational pull as their larger counterparts. While we haven't directly observed primordial black holes yet, their existence is predicted by our current understanding of the early universe. Scientists believe that these miniature black holes could account for a portion of the universe's mysterious dark matter. If primordial black holes do exist, they could have profound implications for our understanding of the universe. The search for primordial black holes is a challenging but exciting endeavor, pushing the limits of our observational capabilities. Chapter 6. The Cosmic Web. Our galaxy, the Milky Way, is just one of billions of galaxies scattered throughout the vast expanse of the universe. But these galaxies are not randomly scattered. They are organized into a vast and intricate cosmic web, a network of filaments and voids that stretches for hundreds of millions of light years. Imagine a giant spider web, its delicate threads woven together to create a complex and interconnected structure. Now, replace those threads with galaxies, clusters of galaxies, and vast cosmic filaments of gas and dust, and you start to get a picture of the cosmic web. At the nodes of this cosmic web lie massive clusters of galaxies, gravitationally bound collections of hundreds or even thousands of galaxies. These clusters are the cosmic cities, bustling with activity as galaxies interact and merge, their stars swirling in a complex gravitational dance. Connecting these clusters are long, thin filaments of galaxies and gas, stretching across hundreds of millions of light years. These filaments act like cosmic highways, channeling galaxies towards the denser regions of the universe. So the next time you gaze up at the night sky, remember that our galaxy is just one small part of a much larger and more complex structure, a cosmic web that stretches across the vastness of space and time.
Chapter 7. Venus in Retrograde. In our solar system, most planets rotate on their axis in the same direction as they orbit the Sun. It's like a cosmic ballet, with each planet spinning gracefully as it waltzes around our star. But Venus, our enigmatic neighbor, decided to be a rebel and dance to its own tune. Unlike Earth and most other planets, Venus rotates on its axis in the opposite direction of its orbit. This means that on Venus, the sun would rise in the west and set in the east. A truly bizarre phenomenon for anyone used to Earth's celestial rhythms. Imagine standing on the surface of Venus, if you could withstand the intense heat and pressure. As you look up at the sky, you'd witness a sunrise that seems to defy the laws of nature, with the sun slowly creeping over the western horizon. But why does Venus spin backward? Astronomers believe that this retrograde rotation is the result of a cataclysmic event in the early solar system, perhaps a collision with a massive object that knocked Venus off its original axis. Venus's retrograde rotation is just one of the many mysteries that make this planet so intriguing.
Thanks for watching. If you enjoyed these mind-blowing space facts, don't forget to like, comment, and subscribe for more fascinating content. There's still so much more to explore in the vast expanse of the cosmos, from the mysteries of black holes to the search for life beyond Earth. Keep looking up, keep asking questions, and keep your sense of wonder alive. See you next time.